Hi everyone, so this is a video that explains how I did all the problems on exam 2 and explains how you can grade yourself, how many points to give yourself for each part. So let's start with problem 1. The directions were to differentiate implicitly. So if I'm going to differentiate x cubed y squared, then it's going to be, this is a product, x cubed is my f, and y squared is my g. So I'm going to do g times f prime plus f times g prime, and since it's y squared, this is 2y times y prime. Then plus the derivative of e to the y, which is its separate term. Derivative of e to the y is e to the y times y prime, and the derivative of 8 is 0 because it's a constant. Now I'm looking at having two terms that have a y prime, so I'm going to keep those on one side and factor out the y prime. That's going to leave me with a 2x cubed y plus e to the y, and this term y squared times 3x squared does not have a y prime, so I'm going to move it to the other side and end up with a negative 3x squared y squared. To solve for y prime, I simply divide both sides by 2x cubed y plus e to the y. So I end up with negative 3x squared y squared over 2x cubed y plus e to the y. I'm sorry, I wrote that wrong. Plus e to the y. That's my final answer, and that's worth a full 12 points. Okay, if you notice on the answer key, if you differentiated this product correctly, this part here was worth 6 points. The points are also on the answer key. If you differentiated this correctly with the chain rule, that was worth 1 point. If you got this derivative being 0, that was also worth 1 point. Moving this to the other side was worth 1 point. Factoring out the y prime was worth 2 points. And your final answer, overall, cleaning it all up, dividing both sides, was worth 1. Okay, so overall we have a total here of 12 points. You can assign yourself a score for number 1 of a certain number of points of 12. Okay guys, this is problem number 2. We had our height function as negative 16t squared plus 48t plus 160. In part A, you're asked to find the velocity. That means I'm taking the derivative. That's going to be negative 32t plus 48. Okay. When is the maximum height reached? That's when the velocity is 0. So if I set negative 32t plus 48 equal to 0 and solve, I end up with 48 over 32, or 1.5 seconds. That's when the maximum height was reached. What is that height means plugging 1.5 into my original function, and if I do that, negative 16 times 1.5 squared plus 48 times 1.5 plus 160, I end up with a maximum height of 196 feet. That's for part B. Part C, what is the velocity when the ball hits the ground? First I need to find when the ball hits the ground. That's when the height function is equal to 0. If I factor negative 16 out of that, I've got t squared minus 3t minus 10, which is factorable to t minus 5 and t plus 2. Solving each of these, I end up with t is 5 or t is negative 2. Negative 2 for t would be 2 seconds before the ball took off, so that doesn't make sense. So my time that I'm looking for is 5. But it asks me for the velocity when the ball hits the ground, so I'm looking for the velocity when time is 5. So now I'm going to plug that into my velocity function, and I end up with a velocity of negative 112 feet per second. Okay, those are my answers for number 2. Here's how the points go. 2 points, give yourself 2 points if you got the velocity right for part A. In part B, if you set it to 0, that's a point. If you solved for the time, then that's another point. And if you found the height correctly, that's 2 points. So overall in part A, it was 2 total. In part B, it was 4 total. In part C, if you set the S of t function equal to 0, then that's worth 2 points. Once you factored and solved, that's another 2 points. And then plugging in here and getting the correct velocity, that's another 2 points for 6 points overall, 12 points for this problem. So give yourself a score out of 12 for number 2. Okay guys, here's problem 3. You needed to choose 3 out of the 4 functions to differentiate. So you may not have done A, but I'm going to go through A, B, C, and D. So A was f of x is x cubed over cosine squared. That's a quotient, so I need to use the quotient rule. So the derivative is going to be g times f prime. That's cosine squared x times 3x squared minus f times g prime. X cubed, cosine squared is going to be 2 times cosine times the derivative of cosine, which is negative sine x. And all of that is going to be over g squared, so cosine squared squared, or cosine to the 4th. Okay? If I look at the top, I clean it up and I pull out a common factor, I see that they both have x squared, and they both have a cosine x. So if I pull out an x squared and a cosine x, I'm left with 3 cosine x minus, here this negative times negative is going to become positive. I've got a plus 2x sine x. On the bottom, I still have cosine to the 4th x. And if I look here, I've got 1 cosine here, 4 on the bottom. I can eliminate 1, and this drops to cosine cubed. So my final answer here would be x squared times 3 cosine x plus 2x sine x all over cosine cubed x. Now, if you distributed this back in or you didn't factor out the x squared, then that's fine. I would also accept an answer of 3x squared cosine x plus 2x cubed sine x all over cosine cubed x. But you need to have at least factored out the cosine and reduced it with the cosine to the 4th on the bottom. Each of these in number 3 was worth 6 points. So if you correctly apply the quotient rule here, that's a total of 3 points. And then if you ended up with either of these 2 answers, then that's another 3 points for part A. Right? Let's take a look at part B. Part B here was y equals 3 to the 2x plus 7. This is 3 to the something. When I go to differentiate this, the derivative of 3 to the something is 3 to the something. So 3 to the 2x plus 7 times the natural log of 3 times the derivative of the something, that's the chain rule, and the derivative of 2x plus 7 is simply 2. Not a whole lot you can clean up here. This is a base with an exponent. It can't be combined with the 2 or this. So really that's my answer. Maybe you could write 2 natural log of 3 times 3 to the 2x plus 7. Excuse me. But that's pretty much it. Okay? So essentially for this one, again, it's 6 points. You get 2 points for each part. 2 points for the 3 to the something, 2 points for the natural log of the base, and 2 points for applying the chain rule there. That's parts A and B for number 3. Now let's take a look at part C. This was also worth 6 points. Problem C, I have g of x is equal to the inverse sine of 4x. Okay. The derivative of inverse sine is 1 over the square root of 1 minus that something, that's the 4x squared. Then I apply the chain rule times the derivative of the something. The derivative of that something is 4. So I end up with, if I clean it up slightly, 1 times 4 on the top, and on the bottom, if I square this, 1 minus 16x squared. And that's my final answer for part C. You get 2 points for getting this part of the formula right, 2 points for applying the chain rule, and 2 points for cleaning it up. 6 points overall for that one. Okay. Lastly, D was a natural log function. Part D, I have h of x is equal to the natural log of 3x to the 4th plus 8. The derivative of the natural log is 1 over 3x to the 4th plus 8, right? Derivative of natural log is 1 over that something times the derivative of the something applying the chain rule, and the derivative of 3x to the 4th plus 8 is 12x cubed. So I end up with 12x cubed over 3x to the 4th plus 8. That's my final answer there. That was again worth 6 points, and you get 3 points for getting this part and 3 points for applying the chain rule there. Okay, again, you only needed to do 3 out of the 4 problems in number 3, so you should have a maximum of 18 points for number 3. Okay, in number 4, your directions were to differentiate this function logarithmically. It's sine x to the power of x. So before I start to take the derivative, I first need to take the log of both sides. That'll get my x out of the exponent. So if I take the natural log of both sides, I'm not taking the derivative yet. I'm just taking the natural log of the left side, and then I take the natural log of the right-hand side. When I take the natural log of the right-hand side, properties of natural logs allow me to move this to the front, and I end up with x times the natural log of sine x. Now I'm ready to differentiate both sides. So now I'm going to take the derivative with respect to x of all of this, and I'm going to use implicit differentiation here. Derivative of natural log of y is 1 over y times the derivative of y. And then here I have a product, so I'm going to apply the product rule. Here's my f, here's my g. So I'm going to do g times f prime. That's going to be natural log of sine x times the derivative of x, which is 1, plus x times the derivative of natural log of sine x, which is 1 over sine x times cosine x. Okay, if I clean this up a little bit, I end up with y prime over y on the left. Here I have natural log of sine x, and here I have x, and then this is cosine over sine, which is cotangent. So I end up with x cotangent of x. Remember, my main goal is to solve for y prime, so that means I need to multiply both sides by y. So y prime is going to be y times natural log of sine x plus x cotangent x. And since I knew what y was from the very beginning, then this can come down here. And my final answer that I was looking for was sine x to the power of x times natural log sine x plus x cotangent of x. And that's the final answer for your full 12 points there. So if you took the natural log in terms of points, if you took the natural log of both sides and used the natural log properties, okay, then that's 2 points there, getting us all the way down to here. Once you take the derivative and you differentiate, getting this left-hand side is worth 2 points. Differentiating using the product rule is 2 points for each term, so 2 points for this term, 2 points for this term. Simplifying and cleaning it up, so particularly getting that cotangent here, that's another 2 points. And then solving for y prime and plugging in y, your final answer is worth 2 points. Okay, so overall we've got 2, 4, 6, 8, 10, 12 points. Give yourself a score out of 12 for number 4. Okay, here's number 5. We need to find the equation of the tangent line to g of x is square root of 1 plus 6x squared when x equals 2. To find the equation of the tangent line, I need the slope of the tangent line. That's going to come from the derivative. So I need to find the derivative here, This again would be the same as 1 plus 6x squared to the 1/2 power. So if I find the derivative, it's 1/2, 1 plus 6x squared to the negative 1/2 times the derivative of 1 plus 6x squared, which would be 12x. If I clean that up a little bit, I've got half of 12x. That's going to give me a 6x on top. And then 1 plus 6x squared to the negative 1/2 is the same as the square root of 1 plus 6x squared in the denominator. Okay? If I want to find the slope of the tangent line, then when x is 2, that means I need to find g prime evaluated at 2. So I'm going to plug in here 6 times 2 over the square root of 1 plus 6 times 2 squared. That's going to give me 12. Here 2 squared, 4 times 6, 24 plus 1, 25. Square root of 25 is 5. So my slope is 12/5. But in order to come up with the equation of the tangent line, I also need a point that I go through. So I also need to find g of 2, which means I need to plug 2 into my original equation. That's going to be 1 plus 6 times 2 squared. That's going to be 5. So I'm going through the point 2, 5. Here's my point. Here's my slope. I put these two together in point slope, and I end up with y minus y1 equals my slope 12/5 times x minus x1. If I clean this up, I end up with 12/5 x. Here I end up with a negative 24/5. I add that 5 to the other side, which is like 25/5, and my final answer is 12/5 x plus 1/5. For the full 14 points, you needed to get all the way to there. Let's break that down. If you got the derivative, okay, that was worth 6 points here, correctly finding the derivative. Correctly evaluating the derivative at 2 and getting the slope, that was worth 3 points. Correctly finding the point that we go through, that was worth 2 points. Okay, and then correctly plugging in and getting all of this was worth another 3 points. Okay, so that's a total of 14 points for problem 5. Okay, here's number 6. You needed to differentiate each function. They look similar, but each one had a twist. In part A, you're differentiating x squared cosine x. This is a product. Here's my f, here's my g. So if I'm going to differentiate this, I'm going to use the product rule, g times f prime. That's going to be cosine x times 2x plus x squared times the derivative of cosine, which is negative sine x. You needed to clean that up a little bit. It's going to be 2x cosine x minus x squared sine x. Each of the problems in number 6 was worth 6 points. Okay, to get each of these terms, you got a plus 3 for this term, plus 3 here, 6 points overall for part A. Let's look at B. B was a chain rule. This is the derivative of cosine of x squared. There's no product here. When I go to find the derivative here, it's going to be derivative of cosine of something, that's negative sine of x squared times the derivative of that something, which is 2x. My final answer here is going to be negative 2x sine of x squared. That one with the chain rule, if you had this part, you get 3 points here and 3 points for multiplying by the derivative of the inside function. But I really want you to come up with kind of the complete answer there for a full 6 points. Last one here for number 6 was part C. This is differentiating x, cosine x, and then the whole thing there is squared. So now I have a product to a power. So overall I'm using the chain rule. So the chain rule, this is something squared. Derivative of that is 2 times that something to the first power. Don't have to write that first power in there. And then multiplied by the derivative of the something, derivative of x cosine x. Now that's a product. So if I'm taking the derivative of the inside, which is a product, that's going to be cosine x times the derivative of x, which is 1, plus x times the derivative of cosine x, which is negative sine x. If I clean that up, it looks like 2x cosine x times cosine x minus x sine x. And you don't need to distribute any further than that. You can leave it in that form for part C. Okay, in terms of the points here, you've got 2 points for this first part of the chain rule and 4 points for correctly doing the product rule there, gives you a total of 6 points. Okay, each part A, B, and C was worth 6 points for number 6 for a total of 18. All right, our last problem on the exam, number 7, I needed to find the second derivative, which means I need to differentiate twice. Okay, if I take the first derivative here, I end up, this is 2 separate terms, so I can take the derivative separately. 3x squared, use the chain rule to differentiate sine of 3x. That's going to be cosine of 3x times 3. Okay, which means my first derivative is 3x squared minus 3 cosine 3x. Okay, then I need to take the second derivative of that. Again, these are still 2 separate terms, so I take their derivative separately. Derivative of 3x squared is going to be 6x minus derivative of 3 cosine 3x is going to be 3 times the derivative of cosine, which is negative sine 3x times the derivative of 3x again, which is 3. Clean that up a little bit and I end up with 6x minus that negative is going to become a plus. I got a 3 times 3 plus 9 sine of 3x. Each problem part here was worth 7 points. You get 3 points for correctly getting to the first derivative and another 4 points for correctly getting to the second derivative. So 7 points total for correctly ending up at f double prime of 6x plus 9 sine 3x. Okay, let's look at part B. B was a product, x cubed times sine x. So if I want to find the first derivative here, I need to apply the product rule. Here's my f. Here's my g. So it's going to be g times f prime plus f times g prime. Okay, so I'm looking at sine x, 3x squared, so that's 3x squared sine x plus x cubed cosine x. Okay, this one's going to take a little bit more work when I go to find the second derivative because now I have 2 products added together. I need to take the derivative of each term separately. So I'm going to take the derivative of 3x squared sine x first. Again, here's an f. Here's my g. That's going to be sine x times the derivative of 3x squared, which is going to be 6x plus 3x squared times the derivative of sine x, which is cosine x. That takes care of the derivative of the first term. Now I'm going to do the second term, another f, another g. So I'm adding on to this what I get here, g times f prime cosine x times 3x squared plus x cubed times the derivative of cosine x, which is negative sine x. Now I got to clean that up a little bit. I end up with 6x sine x plus a 3x squared cosine x. Notice I have another 3x squared cosine x coming here, which means altogether I have 6x squared cosine x minus x cubed sine x. So there was one pair of like terms here, and I combined for a final answer for my second derivative of 6x sine x plus 6x squared cosine x minus x cubed sine x. If you got the answer to the first derivative, that's plus 3. Getting all the way to the second derivative is another 4 points. 7 points for part A, 7 points for part B, 14 points overall for problem 7. Okay, so you saw me go through the answers for each of the 7 problems and the scoring for it. There's also the answer key that I posted. You can check that for scoring information. Do the best you can to give yourself a score on each of the 7 problems. Fill that in. Number 1 out of 12, 2 out of 12, number 3 was out of 18, number 4 was out of 12, number 5 out of 14, number 6 out of 18, number 7 out of 14 gives you a total score out of 100. add that up, email me your score, come and see me in office hours if you have a particular question that hasn't been answered or you're not sure quite how to score it, but email me your score and that's going to be your score for exam 2. If you have any other questions, you can ask me in class or ask me in office hours tomorrow.